Is the stream live? Nice. I think we're live, guys. Okay, let me just set up things here. Huge delay today. I had a meeting with Christopher from Lion, trying to figure out the best thing to do when it comes to compute and what's the best way to basically make the future of this project bright. And so he's been one of the persons I've been talking with. Let's maybe wait a couple of seconds for some of the people from Discord to join. I'm gonna also just announce. Let's go here. Get a delay setting up my gear. Plus the longing. Okay. We are good now. I don't want to spam anyone else. Maybe just if I do this. So who wants to stay in the channel can stay in the channel. Otherwise you can just leave the channel. Okay. I don't see the chat. Is anybody... Sarah, can you try typing in something? Live chat. Okay, I see live chat. Guys, you see this? And let's just see how big of a delay we have. I think it's maybe 5-second delay. You're live. Awesome. Okay, so where we stopped yesterday, we went through the seamless M4T paper, which is a new work from Meta. We went through the paper over the first two streams. The third stream, we went through the data sets that they use for the primary data set. And then we figured out the licenses there. So here is a set of the data sets we found. And the green ones are basically the permissive licenses. And the rest are non-commercial. So yeah, we're gonna figure out details here. If we go via some nonprofit, if we collaborate with nonprofit organization like Lion, then we won't have a problem, any legal issues, I think, to just train open source checkpoints. That's why I'm considering collaborating with Lion. Let's just see here. Okay. Can we use laser to mine data? A couple of things. I reached out to Yannick Kilcher as well because he was a part of an open assistant effort just to figure out, hear a bit more about his learnings. So now let's go. I think there's a couple more data sets I have to figure out the license for. So if we go to NLLB GitHub and let's find the data sets. Data set section, so it's here. I think this is where the README is. So yeah, there were a couple of data sets we did not go through because they are not automated and they are not in the download script I was looking in. So let's just check out the licenses for these three data sets here. And then I think a good idea would be to just go through the Laser 3 codebase and figure out what's the best way to train it. Okay, license here. License, I don't see the license on this one. There is the Eve. Wait. Eve language corpus, Lorelei. Okay. And this is the Chicheva news, whatever that means. Do you guys see the license here? Site collection was supported by the AI4D Language Fellowship. Closed access. Closed access, okay. That probably implies these are not gonna be non-commercial. Let's see whether they say anything about that. I don't see. The dataset contains of articles with news in Chicheva. The articles come from 3 large news publishers in Malawi: The Nation newspaper online version, the Malawi Broadcast Corporation, and Radio Maria. The articles presented in the dataset are full articles and span many different genres, from social issues, family and relationship, blah, blah, blah. Is my audio okay? My audio okay, guys? The articles presented, okay, we read that. Split into 3 sets, 19 categories. Okay, I'm gonna assume that this one is non-commercial. Okay, let's see this one. License unknown. When the license is unknown, then you just assume it's not for commercial use cases. Oops. Okay, and then the final one here. User agreement for non-members. Oh my god, look at this. Scary. Commercial. Only for non-commercial linguistic education. Okay, this is also non-commercial. Okay. Sounds good. Let's figure out a little bit about laser today. So I'm going to focus on laser. Let's go here. Laser 3. Encoders and mine bytext metadata are open sourced in laser repository. Let's go there. Okay. So this is also Meta's work. Blah, blah, blah. Let's see what they say about licensing here. Switch to BSD. BSD licensed. Is that a non-commercial license? I have no idea. Let's use our friend ChatGPT here. Okay. Is BSD license non-commercial license? How does it compare MIT Apache and GPL? Is not strictly a non-commercial license. It's a permissive open source license that allows both commercial and non-commercial use of the software. However, it has some variations, such as the 2-clause BSD and 3-clause, that come with different levels of permissions and requirements. Generally, the BSD licenses allow you to use, modify, distribute, and sub-license the software without many restrictions. Permissive and simple allows both commercial and non-commercial use. Hi, Luca, welcome to the stream. Requires that the original copyright notice and disclaimers are retained. Okay. Got it. Okay, that seems like that's a permissive license, right? So redistributions of source code must retain the above copyright notice. Okay. It would be cool to analyze this repo, see whether they have some checkpoints, and then maybe try and do some mining before, in case the checkpoint is not permissive, then we'll have to train laser as well. Let's figure out those details first. References. Oh, wait. We actually care about not laser, we care about laser 3, right? Is this a different repo? Okay, it might be. As part of the no language left behind project. So we can train them. And the training code is where? I won't be focusing on anything that's off topic here in the stream. I'm going to just focus, unless you have questions regarding NLLB, I will just be focusing on this for now. Hope that makes sense. Okay, there's just so many links here. This is annoying. Why don't they just point me to the laser 3 training code? No worries, man. All fine. No worries. Quantum. Are there any checkpoints here? Let's first find the checkpoints. I don't see here. Is there any checkpoint here? Any checkpoints? Let's see where our laser 3 hugging face. Sonar. I don't see any of the checkpoints. It definitely seems like laser should be here. Checkpoints, where are the models? Let's see whether the issues have any additional information. Hmm. Okay. So laser 2, you can download the checkpoints here. For laser 3, there is only encoder. Both pre-trained checkpoints contain only encoder. So that's a complete checkpoint apparently. Here is the training code for laser. Let me just group these guys. Just trying to organize myself a bit. Okay. So this is how we embed once we have the models. But where are the models? Why is this so hard to find just the checkpoints? That should be obviously stated in the first part of the README, basically. What's the difference between all of these READMEs, man? What's this? Containing source code for training. Isn't that the same as this one then? Okay, this is not laser 3. Okay, we can ignore this one. Okay. I didn't see this one. Run this script. I already have my NLLB project set up, so this is going to be easier than I thought. Downloading all laser 3 encoders may take up a lot of disk space, therefore you may choose to select individual encoders by supplying a list of available language codes. Okay. Each focus language. What's a focus language? Okay, so this is everything we need to get started. I'm just curious, I'm not sure whether we can use what's the license of the checkpoints. Bash embed sh. Is this the same link as this one? Just trying to map. Yeah, this is the same one. So what's the difference between this embed script and the other one? You know, try both of them. Did we try this already? Hi there. Okay, to the best of my knowledge, this looks like everything is BSD. Let's try and confirm that quickly. Okay. Let's start and do this. So this is the NLLB branch of the FairSec codebase. Let's just find this. So we're looking for download models sh script. Let me know, guys, if you can see the screen. I can't find it. Why is that? Okay, this is a different... Okay, I will zoom a bit more. I don't know, it's gonna take weeks, if not months, to replicate everything. Okay, do have to clone this repository. How can I sustain myself? Well, I didn't have really big expenses while I was working at big tech over the last years, so I have a lot of savings. I have enough savings not to have to think about that too much. And investments. I mean, unless you're a parent and you're spending all of your money, I'm not sure how can you not have enough money after having worked at big tech for multiple years. I'm not sure what other people are doing with their life and spending, but you get enough money so that you don't have to really care. Okay, let me see. Let me open up another VS Code instance. New window. Let's open up. Where did I save this? I'm still getting used to Ubuntu. Okay, where is laser? Why don't I see laser? Sec. Oh, NLLB. Laser. Open up this one. Find the download models sh script. Wait, where is this? Just a second. Under NLLB, download models. I'm not sure why I didn't pick it up immediately. Okay, here it is. So this guy is going to download. Let's try a couple of models. Let's just experiment a bit here. Maybe download a couple of checkpoints and embed some sentences. Well, I mean, even with 10K savings, I don't know, like in a couple of years, that's enough to give you some runway, right? What's the environment setup here? Anything else? Set the environment variable laser to the root of the installation. Download encoders from Amazon by calling this. Download third-party software by calling install external tools. Download the data used in the example tasks. Okay, let's see what the external tools script does. Download data using the example tasks. See description for each task. Let's see that. What happened with my VS Code? Did it crash? Ubuntu is not really stable compared to Windows. These things happen every now and then. Things not working. Okay, this installs tokenization tools from Moses. Detokenizer, some Perl scripts. Guys, it's going to be hard to follow any topic unless it's related to what I'm working on right now. Otherwise, too much context switching. I think most of the things you're asking there, I wrote in some of the blog posts as well. Remove the escape. Okay, let's download these tools. Although I'm not sure whether we actually need them. This is for, maybe, just maybe, once we download the models, let's see what then. Then to run them by following the instructions here, for example, embed sh. So we have to call embed sh. I think this is the same. Oops, this is the same file as this one, right? Yeah. So we just call the embed sh script under embed, which is under tasks. Okay. Let's see what it's asking. So if we go under tasks, embed sh. Why is it using laser 2? Why not laser 3? Is there any Perl script we'll be using here? Any processing? By the way, I'm gonna use ChatGPT to parse all of the. I hate bash, but like I'm slowly figuring out the syntax. I'm just Googling and using ChatGPT. I'm not internalizing the syntax, but I really need it because people love bash. I hate it. Okay. Let's just download a couple of models. If I set one here, does that mean which version do we need? So we need a couple of arguments for this script. Okay. Well, let's do that. Let's take some of the languages. Let's maybe take English and Spanish. Interesting. Why don't we have those languages here? These are all some low resource languages. Where is German? Where is Spanish? What is this? Okay, let's just take some. Yeah, we'll need a bunch of GPUs to do the mining. It's open up the NLLB paper and just search for GPUs. I think they mentioned some numbers and some compute hours as well. I think they used 8 or 16 GPUs for mining. Yeah, let's just run the script, see whether everything works. I'd love to understand how it works first. Let me just see what it does. Let me open up. Let's first navigate to laser. And then let's call the script. So we have to set first the environment variable for the laser route. That's what I said. Projects. Okay, that looks okay. And now we want to run from here. So we have to exit and then enter NLLB and then call the download models. And we're going to take an arbitrary data set. Pick Hindi. Okay, let's go with Hindi. But I doubt they have Hindi. Oh, they have Hindi. Okay. Because I thought that Hindi is probably a high resource. Let's see whether this works. Directory for model downloading. Okay, let's see what's happening. Let me open up another window. While it's working on that, let me see. So it takes the directory here, just from the current working directory. That's why I navigated here to laser encoders. Version 1, downloading networks. If it doesn't exist, then we create one. Then there is the download script, takes the arguments. If that does not exist, okay, if it exists, then we already downloaded it, otherwise we try and we download the model, okay. We change the directory there. S3 bucket link. They have used 16A100. Yeah. 50,000 hours for everything. They also trained the 54 billion parameter mixture of expert models. So that's not what we need, right? we won't be training the mixture of experts. We're going to focus on training dense checkpoints. Start with 600 million and then push all the way to 3.3 billion and then probably go even beyond, but then scope the languages from 202 supported languages to only focus on a particular family group. That's how I'm thinking about this. What does this exactly do? I mean, I understand the semantics. We're just basically, if we don't specify the arguments, then we pick all of the languages. I did specify, so let's just see. I always forgot this. Okay, if it's not equal to 0, so if we have non-zero number of arguments, so this is the number of arguments, if that's not equal to 0, then we, okay, nice. That's how I'm using ChatGPT, by the way. It helps a lot to analyze some of these script files. And then we go through all of the languages. What's this, by the way, this syntax here? Anybody knows this? I mean, I understand the semantics again, but it's just, we're iterating through the array. We're going to use some grants, or we'll see how it goes. That's why I'm talking with Lion folks. Aha. So this symbol ensures that all elements of the array are expanded. Okay. Weird syntax. So then we download for that language, that particular version. And then for SPM languages, if we picked any of these, then we additionally download 2 more models. Okay. Where is Hindi? Which one? Hindera. Okay, Hindi is not among these languages. Okay. Cool. So that's that part. So now let's try and just embed some text. Now I need some Hindi. Can somebody paste me like a Hindi sentence? That's not a curse or something, otherwise YouTube will kick me off the stream. Please be aware of that. Don't exploit your power. Okay, let's see how we can embed. Let's open up the README here. So embed input file, output file, language. The input will first be tokenized and then sentence embeddings will be generated. If a language is specified, then it will look for a language-specific laser 2 encoder using the format. Otherwise, it will default to laser 2. Please set the model location in embed before running. We recommend to download the models from the NLLB release. Optionally, you can also select the model version number for downloaded laser 2. This currently defaults to 1, initial release. Okay, let's set the model directory here. So we are here. Thanks, Asim. Copied it from Google. Okay, fair enough. Okay. Let's embed this bad boy. Okay, so we need a couple of things. We need to create an input file. So let's navigate. Let me grab this one. Let's go to tasks. Let's go to embed. So we're gonna run the bash script from here. We need to specify the input file. So let's do it like this. Let's create a new file. I'm gonna call the file input and then in Deva, that was the name, right? And then let's just call it like a text file. And then thanks to a theme, I'm gonna paste this piece of text. Let me see what it means first. Google Translate, Hindi. Do you speak Hindi, by the way? Okay. Although there are many legends about Sur's life, it is difficult to say how much truth is there in them. It is said that he was born in 1478 in a poor Brahmin family near Delhi. Awesome, cool. So this is indeed Hindi sentence. Let me save that file here. Let me create another file called output in deva.txt. And let's now call this. Let's open up the, so we need bash, and we're gonna do the following. This is the call command. We want in the deva. We want output file here. And we want input file here. This should be it, guys. Let's see whether this is going to work. Let me run it, and if it's failing, we can just figure stuff out. Okay, so it says import numpy as np, no module named numpy. Okay, there are some dependencies here that I did not anticipate. I thought that, okay, so it's actually calling, okay. So what I have to do, I guess, is I'm gonna do the following thing. Let me just, can't see the chat. Let me just put here. Okay, now I can see it. So let me panda activate NLLB. And let's now rerun this guy. Okay, there's another error. Let's see what's going on in the script. Sorry, Asim, I'm not sure what you mean when you said no. What are you referring to? If number of arguments smaller than 2, then okay, input file language. You don't speak Hindi, sorry. There is a lag, so I didn't losing my context. I have two RTX 3090. That's what I'm gonna be using. I can show you maybe on the stream later how my setup looks like. Digital Dragon. Or maybe, nah, I have the chroma. Maybe I can just take a picture and, but yeah, maybe I can do it later. I'm gonna show you the setup a bit later. Okay. A couple of files here, PT, Hindi Deva PT, SPM, and vocab. So this is the tokenizer, I guess. Luca, everything is going super well for now. Trying to debug why I'm getting some failure when I'm attempting to embed a Hindi sentence using laser 3. Let's just see what's going on. So model file laser 2. Is 4090 better than 2 RTX? I don't know. Depends what you mean better. 2 of these GPUs have more memory, and cumulative compute power is certainly bigger. Laser 2. Thanks, Luca. Laser 2 SPM. Okay. If it's not 0, then we pick a model file that's specific, laser 3, and we pick a language specific SPM as well. And then what is the S? What does S stand for in Bash? Size greater than 0. Okay. So what was our error? We did call the embed, right? Aha. Okay. We did not download the external tools. I should have checked the error first, but I wanted to analyze the script either way. Okay. Okay. We can do that easily. I'm just trying to see whether it picked up the right models here. Let me just comment out this for a second. And let me just echo the model file and the SPM. Let me rerun this. Okay, so what it picked up is laser 3, that's the specific model we did download, and then the SPM, it tried to find laser 3 specific SPM, but we did not download that one. So does that mean that the download script maybe failed, or aha, no, it's just that SPM. Yeah, you have to be this SPM specific language, which Hindi is not. Hindi is not. That's why we don't have this guy here. Okay, that looks to be okay. So I mean, we can revert the changes here, save this. Let's run the install external tool script. Let's see what it does first. Okay. So just see for a second. How comfortable are you guys with Bash? I'm a big proponent that all of this should be done in Python, just Python. There is no reason why you have to learn a ton of different weird syntaxes, especially back at Google. There's so many domain-specific languages, you can't pick up all of them. Make directory, takes the first argument that you pass to it, and if it does not exist, you create it. Okay, fair enough. Bash is weird, yeah. I mean, you can learn any language. It's just why would you have to learn weird syntax? It gets easy, honestly, if you just play a bit with it, but I don't know. Okay, tools external, we make this, okay, and then tokenization. So here is the Moses Git, here is the Moses file. So what this function does, it creates a directory, it makes it, we change, okay, we do cd into that directory, and then for all of the files above, so here's the same syntax. I'm already picking it up. So for iterating over the array above, we base name, Okay, if it doesn't exist, then we download it. Then we change the execution to, we change it to executable for the current user for all of the Perl scripts, and then again some non-breaking prefixes directory, make a directory with cd there, and then we iterate through the non-breaking languages. We construct a file like this, and we download those as well. Okay, so that's the, so this guy just installs a couple of these scripts. And then fast PPE. Yeah, I'm going to use these streams, guys, to learn as well. So I'm going to take my time and not really rush, because I'm planning on streaming every single day or the next days and just spend a ton of hours to learn stuff and build this. Okay. If fast PPE / fast does not exist, what's X? Oh, ChatGPT, my old friend. Aha. If it's not executable. Okay. So either if it does not exist or if it's not executable, we download the BP software, unzip, we remove the master zip. Okay, and then we do some compilation using G++. And if this equals 1, then we failed. Otherwise, we call Python setup py install. Fair enough. I think we should create a separate conda environment for this. That's why I'm analyzing the code. Let's just see what this means. I'm curious. It's checking the exit status of the previous command. If the exit status equals 1, then the code inside okay, understood. So if there was any error, then we just print the echo. Okay, and then let's see sentence piece. If this directory does not exist, then we download it. If SPM encode does not exist, if the size is 0, then we build code. We go here and we build, okay? Install Japanese tokenizer Mecab. Anyone from Japan on the stream? Let me just invite a couple more people here. Is this the right stream? No, this is studio. Can somebody paste the link of the stream? Configure prefix make install. Okay. If you can just paste the link, just go to my YouTube channel and paste the link so we can share it and invite more people from Twitter and LinkedIn. I'm gonna announce the schedule. I'm gonna make this a bit more. I'm gonna do a bit more marketing over the next days as soon as we get into some rhythm. Okay. So we install all of these and then we install Mecab. Sounds good. There are no arguments, so that's why you call it like this. And that's all. Okay. I think it might be a smart idea to just create a new Conda environment to run this. Let me see the source embed.py, what's going on there. So if we go to source embed.py, torch and stuff, fairsec. I'm gonna use the same environment because they don't have any requirements file here or anything, so I'll be just hitting a bunch of issues. So let's do it like this. Let's just run this script directly. I don't see the link. Asim, probably. Let's just first run the script. I think that YouTube might be blocking your URLs. Maybe it considers those links to be like a threat or whatnot. Just a second. Maybe I can just add this one to my bash RC script. Nah, fuck this. How do you show the hidden files in Ubuntu? Visible columns, show hidden files. I need to see the bash RC. Let's just sort this thing. Okay, so that I don't have to do this anymore. Okay, let's run the install script. Errors. Control plus H, thanks. I just found the GUI option. Okay, thanks Future for that life hack. Let me just now share the screen. Okay. I think Twitter and Discord are enough for now. Okay, let's see why this failed. So it was successfully downloading stuff and then it hit the fast PPE line. Okay, downloaded everything. No such file or directory. Fast PPE, fast PPE, CPP. What's up there? Why is it complaining? Let's see what's going on. How do you create an alias in Ubuntu? I forgot that. I want to navigate to a particular directory every time, so I don't want to have to retype that every time. So projects, NLLB, and then laser. And then what I want to do is open up now Utilus and then find tools external, fastbpe. So the CPP file is missing for some reason. Even though this script here, let's see, fastbpe. We get the zip. Okay, and then compiling. So we change, wait, what will we do here? Let's just figure this out. Okay, so we go here and then we open up, so that's here. We have CD once there, and then we have CD once here, and then it tries and do this compilation. fastbp main cc, that thing exists. Huh. Weird. So we need to get this running, because if this is a dependency for embed sh. Without getting this to run, we won't have the necessary tools that we need to run for the embed py, if you saw that before. Maybe we can just go to the GitHub repo and see whether somebody had the same issue. Okay, and then it says automatic installation of the Japanese. We don't care about this part so far, so I think everything worked except for this. So the fastbp did not install successfully. So let's maybe try and ignore this for the second. For the time being, let's ignore it. So let me just note this in my Notion. Okay, let's try and rerun the embed script. Maybe we don't have to care about this for now. Where is my, what's going on? Yeah, FastBP CPP is missing for some reason. I'm not sure what was that about. Maybe we can quickly do this. We can just go here. See whether somebody faced the same issue there. Yeah, okay, first first issue here, but nobody. But again, I don't think we can just try and run this again. Okay, let me just rerun it from scratch. Embed. I think this is how we should do it. Let me just double check that. Okay, so now we basically are not hitting the Perl script missing error. We solved that by installing the external tools. We now just have to figure out what's this. We just have to pip install this probably. Let's see what this package is about. Okay. Some old bidirectional transliterator for Python. Super old package. Let's install it. Okay. I think we should be able to run now. Okay. Let's see. Broken pipe. One issue after another. That's the life of a programmer, engineer, researcher, whatever. No such file or directory. SPM encode. Oh yeah. Okay. So I think that has to do with this thing. SPM encode. I thought that function executed correctly. Download sentence piece and build. Why? Why are you bothering me? Okay, user local bin is missing this file. Okay. What's up here? Let me know if my cookie chewing is too loud. So this failed for some reason. Let's try and rerun the install script here. Okay. That's what I'm going to do. Yeah, now it's skipping because these directories exist. Okay, let's just delete this sentence piece master to trigger this code here. Why don't we have SPM? What's the name of the file? SPM encode. Interesting. If we go and try and find on the root a file that's named SPM encode, will we find anything? Maybe just misplaced the binary. Let me think. I'm getting confused with these terminals, with open terminals. So it said error preprocess SPM encode, no such file. Okay, let's try and find it. Okay, we don't have that file on the system. So something failed. Let's now just, I don't know, let's try and delete this thingy so we can trigger the script. And let's now rerun this guy. Maybe I have to just sudo the script. Let's see what it says here. CMake command not found. On line 135. Do I even have CMake on my system? Is it which or where, or what's the command in? On Ubuntu. Where is? You sure? Let me just see. Okay. Thanks. Thanks, Asim. Weird. Why is it complaining then? Maybe you just didn't find the actual file. Wait. So basically, we enter the build. So when we enter sentence piece, master, which is here, and then we enter build. And then CMake calls with the parent directory, which means sentence piece master. But then it fails. Command not found, make, no target specified, and no make file found. There is no make file here. What's up with this? Let's see whether somebody opened up a similar issue. Somewhere in laser. Just try making, but I don't see the make file. Let's see whether somebody complained about CMake. Yeah, exactly the same issue. We did check that. That's not the case, right? We went to build. There's nothing in our build folder. So this is not the solution. Let's try this manually, but I don't think, I'm not that good with CMake, so I don't really know. So if we go to So I think the issue is ultimately it's not in the path, probably. But then how can various find it if it's not in the path? Should we just do the sudo apt install, or is there anything? Let's just try and run this command. Okay, I think that was it, guys. Nice job. Yep, nice. Okay, let's now see whether... So this guy said, let me just check one thing. Is it in build source? Okay, I see the SPM in code here, so we are good there. Let's just see whether it can be found. Yeah, but it's still not installed here. So we can just copy it there, or let's just rerun the embed script. It's gonna probably fail with the same reason, because I'm not sure if it's smart enough to find the new path. Oh, it is. Wait, this exists already. Maybe we just need to delete it. Wait. So we need to delete it, I guess, and then rerun. Okay, guys. Nice. It seems it's working. So why is this not? This is probably just embedding, right? Not. Yeah. Okay. But this worked. Okay. Cool. So what we are left with, so we had to install CMake on the system. That was the solution, and then build it manually, or just delete the directory and rerun the script. We're still left with this. Still failed the BP. Let's try and, while we are at it, let's try and delete the fast BPE and try and rerun it again. Maybe it was the same issue, right? Let's just delete this guy. And let's rerun the script. Okay, it's a different error. We can ignore it for the time being because this worked. Let's now figure out how can we decode this. Guys, everything worked. Everything seems to have worked. We are now done embedding the Hindu sentence. Let's now check out how the logic works behind the embed.py. Hi, Emery. Let me just think for a second. What have we done? We downloaded the laser models. We ran the external tools script. We fixed some bugs there. FastBP is still not working, so I have a note in Notion for that. So we can fix that later in case there are some issues. But for now, let's just focus on this. Let's understand how this works. Let me just select the interpreter here. We need the NLLB, this guy. Okay. And let's see what's the output. So we are embedding. What we could do is just to get a bit comfortable with this code is visualize the embeddings, take some piece of text, embed those, and visualize the embeddings or something, just to get some feeling for the code base. So here is the main. We pass the input, and we pass the output as well. These two are required. So input, output, verbose, SPM model, and model file. So we passed the SPM and we passed in the model file. Okay. Do you guys hear me well, by the way? Do you hear me eating the cookies? Token lang, what's this? Can we just... We can just run this directly and step-by-step, do a step-by-step analysis. What do you say? I think that's a good way to get familiar with what's going on. Embed sentences, load the model. Yeah, I think that's what I'm gonna do. Let's do that. So let's go to embed sh. Let's figure out what are the inputs. So we have these 5 inputs: input, encoder, SPM, blah, blah, blah. Okay, so let's just do this. Set the breakpoint here. Set this to false so we can potentially analyze code outside of the code base. And then we need the input. Yeah, ASMR. Okay. Copilot helping me there, if you saw that one. Okay, maybe just add number 2 here, otherwise it will not. It will not compute if it sees the file already exists. Encoder. So which encoder did we use? We used this guy. How does one on Windows? You can just click Shift and right click to copy the path of a file. Why don't I see this? Do I have to go to properties and then copy this, or what? How do you do this in? If anybody knows it, just let me know. I want to just copy the path of this file. Or even here in the bar. Okay, I can do it like this. Not perfect, but drag and drop in terminal. Oh, nice. That's cool. Let's try that. Thank you. Okay, encoder. And then what else we need? We need the SPM. I guess it's pretty much the same path, just a different file. So for the SPM model, we're using the laser 2. So we need this guy here, laser 2 PT. Or no, sorry, SPM, right? So for the SPM, we have this guy, laser 2. That should be good. And finally, we can just add verbose, and that should be enough to basically now run this step by step. Let's hope everything works. Nice, guys. Let's see what's going on here. So what are the additional arguments? Encoder, token lang, perform tokenization with given language. For no tokenization, just provide this. Okay, that's currently provided. Well, okay, why wouldn't we tokenize? BP codes. Apply BP using specified codes. Apply SPM using specified language. Wait. I think did we run? I think we ran. We have to pass in the language, right? So yeah, we passed in Hindeva. What are the positional? How do we find the positional arguments? So that's how we called it, and then we passed in this, and then this guy does what? Embed. Where is the embed sh? If we specify the language as the third argument, which we did, if it's not 0, then we just set the model file and we set, and that's it. So we should implicitly be using, this should be ignored, I guess. Verbose, output sentence embeddings. Okay, so that means that this should not be txt, this should just be like this, or maybe emb, just so we know what's going on there. And then buffer size 10,000, max number of tokens 12k, max sentences set to none, fp16, currently we're using fp32, I guess. Use CPU instead of GPU, sort kind, quick sort, Hugging Face, use a Hugging Face sentence transformer. Okay. Let's start stepping through the code and figure out what's going on. Cannot specify both. We specify the SPM model encoder path. Okay, so we're gonna load the model. This is the laser 3 for the Hindu language. So we pass that guy. Okay. CPM vocab. Here is the model we're using. If you can see it. Guys, can you see the screen, by the way? Okay. Thanks, Asim. Are there any special arguments we are passing here? Yeah. And then there is the sentence encoder. This guy is defined here. Let's just briefly go through it. Loading the encoder. Available. Let's load the model. Laser transformer encoder. We pass in the state dictionary and the SPM vocabulary. Okay. We encode that. Okay. Okay, fair enough. And then dictionary. Prepend, beginning of sentence, left padding true. Okay. Use CUDA. Let's see how much memory this guy takes. So currently 2 RTX 3090 GPUs. We can see the consumption here. This is mostly for, I guess, running the monitors or in some additional loads. I'm not sure what, but let's see how that changes once we do this. So we jump to 5 gigabytes. So that's a bit more than 2 gigabytes for this model. Okay, the model is loaded. And then what we do is we create a temporary directory. And then if the SPM model exists, and it does exist, then we apply, we tokenize, I guess, the input file. Okay. SPM language. So input file, SPM model, SPM language. Let's see whether this is going to confuse it. Is it going to ignore? So here is the input file, here is the model, and here is the language. So we tell it we are using English, even though that's not true. We're using Hindu. So let's see whether that's going to confuse it. So lang is set to English. So here is some command. We basically, what we do here is we print the content of the input file, and then we call some of these Perl scripts to remove the non-printing characters, to normalize the punctuation with the language English. So this is where it's gonna fuck it up. Like, it's gonna be using English specific normalization as opposed to using Hindu. So that means that the README is not really correct. You cannot use, they're not calling the script correctly from the embed sh script. So it's on the escaping. And then ultimately we call the SPM encode, and we pass that to the output here. Okay, guys, this makes sense. And now we call run. What's run? Run is just subprocess run. Okay, so that's the Python package, standard library. So one thing I want to change here is we want to change from English to Hindu. But like, I'm still confused. Why didn't they? Probably just a bug. Let's pass in the language. And let's see one more thing before we go there. Let's see whether this script really cares. Normalize punctuation, Perl. So if we go to tools external, and we go to Moses, and we go to tokenizer. So let's see whether this script really cares. Normalize punctuation. Okay. So default English, because I remember this script does not support really a lot of languages. So German, Hindu. Yeah, I think that's the thing. For most languages, it doesn't really matter, including Hindu, I think. You can just use English and the script would do the same thing even if you specified a different language, right? So, by the way, take a look at this madness. Like, somebody actually thought that this syntax makes sense to a human being. This is like... I used ChatGPT to analyze this script before a couple of days ago, so I actually roughly know what's going on. Where can we find these two-letter codes? Let's just see one thing. Let's just see one thing here. Codes. Language. Codes. No, but these are 3-letter codes plus the script. Is it Latin? Is it Cyrillic? Language code. That's the same thing, right? Yeah. How do we decode this? What's which language? Is this some ISO standard or whatnot? I think this is it. So let's see whether Hindu has a... So Hindi is HI. So Hindi is HI. And let's see whether this script cares about Hindi. Apparently not. So for the sake of our example of using Hindi, we don't really care. But like, let's specify a language either way, and then it can ignore it, right? It can just ignore you can ignore the command. Okay, I think we're good now. Okay, let's continue where we stopped. And we were here. Let's execute this processing. And then let's encode a file. So here is the output file here. So, okay, so we just do some logging. We're encoding. So we open our input file. The input encoding is UTF-8, that's fine. And then some error specification here. If length is bigger than 0, then we open the file. And then we open the output file as a binary. And then we call, oh my God, they're using explicit closing instead of context managers. This is probably some old code, but I don't know, weird. So let's go and encode this. So we do buffered read. Okay, just some logic for getting a chunk of the code, and then sentences. And you can see here there is a single sentence. That's exactly the file we passed in. The last character was this weird character. And then we call encode sentences. And then the encoder, which is basically the laser encoder, is going to encode it. The part I'm confused about, let me think. Did we tokenize this beforehand? Let me just check one thing. So when we were here, yeah, SPM, and we need to pipe that here. Okay, but that's a temporary file, I guess. Let's just go back here. Aha. Okay. So here we encode here, and then we process the batch. And then we just, okay, I'm gonna analyze this piece of code again, but for our purpose, we can just push this out to a file, and we are done. Encoded one sentence, and we're done. Okay. Let's just rerun it once more. I don't see the EMB file. Just refresh. Just a second. Let's delete these guys. And let's run this again. Loading the model. And we are here. Okay, let's enter here. So we're tokenizing a line by doing what? Tokens sentence encoder. Okay, so this is just tokenized. And then we just, okay, we fetch from the dictionary everything we need. Okay, fair enough. And then we just yield a batch. Okay, nothing. It's not necessary to go into this function. Batch indices, process batch, that's what I want to see as well. So we push these guys to CUDA, and then we call the laser. Got it. Makes sense. And we get the embeddings, we return this, and then this guy is a tensor, CPU tensor of a shape 1024 floats. Okay. That's it. So that's the 1024 bytes floats, sorry. Okay. Let me just see one thing. Where is this SPM model used? I don't like that we're not using laser 3 here, so I'm not sure whether there is some weird dynamic going on. So SPM model. We pass it there. So are we actually modifying the input file directly? Because I don't see how this is used later in the pipeline. The SPM apply. Let's just jump and do this once more. So let me just add a suffix here like 2 so that we force the recomputation and then rerun it and see what happens in the SPM apply. That's what interests me now. Okay. What happened? Again, run the SPM apply. Okay. So here it is. So it's writing the output to a temporary file. Okay, why? So push this out to a temporary file. Let's just copy this path. Let's open it up. And then so we process using the Perl script, another Perl script, yet another Perl script, and yet another, romanize LC pi, none. And then we concatenate input to SPM. So SPM encode with the model. And we write the output to here. Okay, so let's see again. So currently, if we list here, there is nothing. Once we run this, we should have something. And we do have something. Okay, let's see now, is this a directory? It's not. Let's see. Okay. So this has been processed, the input sentence. But I'm not sure we are actually using this anywhere, right? SPM apply. Okay, got it. Super confusing. So what I've done is they just changed the input file name. Now shows now points to this processed file, and then we pass that to the encoder. That's how they use this component. That's the part that was confusing me. Hopefully that makes sense. Okay, and too many cookies. I think we're good. We now have a embedding vector for a single Hindu sentence. So let's see what's the next thing we could do. What I would love to see is maybe a cosine similarity between a translation of that sentence in English and some random sentence, and see whether they are more similar than some random sentence. Maybe that would be a nice next step to understand. Okay, I'm gonna run this, run all of this, and that's it. Okay, guys, we have the laser pipeline working. That's amazing progress. Maybe we can quickly try and run it for English as well. Let me see whether there is something interesting here to read. This is the training code. Okay. Let's see what's up here. So we can read it in Python easily. Yes, YC is harder for B2C businesses. Historically, just like looking at the patterns that they are picking, it seems they love B2B much more than B2C. Okay, we kind of tested this. Let's see whether I'm missing something. Let me just read this. Okay, yeah, I think we are fairly good here. So this was the laser code base. Let me just read the top level README again. See what else do they support here. Okay, nice. The code to perform bytex mining is now available. I want to check that out. Yeah, let's try this. Bytex mining, that's something we want to try. Can contain words in several different languages. Okay. Aha, so they've listed dependencies here. But they don't have environment file or whatnot. I just use the NLLB environment from that they previously installed. So again, this should be this is the same. Yep, that's the same file. Okay. That's it. So here is the bytex mining. We can run that. Let's first quickly run laser embedding for English. So let's download English. So we are here. Let's go to download script. Where is the download script? Here it is. I have two screens, by the way, so if you don't see what I'm doing, I'm trying my best to keep everything on this screen, but I have another one. By the way, guys, I think my camera is about to die, so in case that happens, I'm gonna end the stream and start a new one. Just FYI. I see that the battery is blinking up there, and unfortunately, it should be charging while I'm streaming, but it's not. I'm using Sony ZV-1 camera. Okay, let's see. Download models sh. Why can't I find the? Oh my god. Just a second. We want to download everything for English language. Let's see how. Download models. There is no user instruction here. I already forgot how I'm supposed to be using it. Yeah, I think we just need to pass in